Hi everyone, welcome to the next lecture in our bit manipulation series. So in this lecture, we are going to cover this problem. Find the missing number from 0 to n. Okay, so let's say we have given an array and it contains number from 0, 1, 2, 4. Okay, so from 0 till n, all numbers are there in our array, but one number is missing. Okay, and we need to find that missing number. So here 0 is there, 1 is there, 2 is there, 4 is there. That means 3 is missing. Okay. Similarly, let's take one more example. Let's say 0 is there, 1 is there, 2 is there, 3 is there. Okay. So that means 0 is there, 1 is there, 2 is there, 3 is there. That means 4 is missing. Okay. So from 0 to n, one number is missing. So let's say if its size is 4, which means that from 0 till 4 one number is missing. That can be 0 itself, then can be 4 itself. Okay, now how we can find that missing number? Okay, so the very first approach comes in my mind. I know the summation, right? I know the summation. So if I ignore 0 for now, okay, what is the summation from 1 to n? So it is nothing but n into n plus 1 by 2, correct? So my idea is, if I found the summation, so let's say n is 4. Okay, what can be my summation? It can be 4 into 5 by 2. That is nothing but 10. And now I keep decrementing the elements which is there. So 0 is there, 1 is there, 2 is there, 3 is there. Okay, so it will give me nothing but 10 minus, this will be 3, 4, 5, 6, 6. So it will give me 4. Okay, which is nothing but our missing number, correct? So the basic approach is, what I can do, I can just find the summation from 1 to n and I will keep decrementing this number. Okay, so it is same as doing 1 plus 2 plus 3 plus till n minus whatever number is there. Okay, all the numbers are there in our array, only one number is missing. So whatever number is missing, let's say 1 is there, okay, 2 is there, 3 is there, let's say n is missing. Okay, so 1 will cancel 1, 2 will cancel 2, 3 will cancel 3, and so on. Okay, and n is not there, so only n will remain. Okay, and that is nothing but our missing number. Okay, so this is a very basic approach. So if I write the pseudocode for it, so let me write the pseudocode for it. What I can do, okay, so let's say this is my array. Okay, I can find the array size. Okay, array size, and array size is nothing but our n only. Okay, so if array size is 4, it means from 0, 0, 1, 2, 3, 4 till 4 numbers should be there. Okay, 1 is missing, so from 0 to 4 numbers should be there. Okay, now what I can do, I can do a summation, okay, using formula. So summation will be nothing but n into n plus 1 by 2. Okay, and I will run a for loop 0 till n, okay, less than n, whatever array size is there. So I can subtract, okay, I can keep subtracting it from summation. So let's say array of I will keep doing this. Okay, and at the end the summation will be nothing but our answer. Okay, so we can return this, correct? That can be our one approach. Okay, so this is our first approach. How much time it will take? So time complexity. Okay, so this is order of one operation, correct? And we are running a one for loop, so it will take order of n time. So time complexity we are taking is order of n. Okay, and what will be my space complexity? We are not using any extra space. Okay, we are using just one variable, so it will be order of 1, correct? Now What's the issue with this approach? What's the issue with this approach? Okay, so the issue is this one. Let's say, let's say my n is int maximum. Okay, and if you do summation int max cross int max plus 1, int max plus 1, it will go overflow. It will go overflow, correct? And here itself it will go overflow. Even if doesn't get overflow here, okay, if a small number is there, it can get overflow here by multiplying the number. Okay, so for small numbers it will work, but for larger numbers it will create an issue. Okay, so what can be my second approach? I can modify this approach. Okay, at the end what I am doing, so let's talk about second approach. So I hope you can code it, right? Nothing much is there, you can code it. Okay, if it will be large code I can code, but it's very small codes. Okay, so in bit manipulation the codes are very small, you just need to understand the approach. So for my second approach, okay, I already told you what I am doing. I am just doing the summation. So summation is nothing but 0 plus 1 plus 2 plus 3 plus till n. And then by running a for loop, what I am doing, I am subtracting 1, then 2, then 3, then 4, okay, then 5, like this till from my array. So this is nothing but my summation. I am finding the summation using formula and then I am keeping on subtracting. But by first finding the summation and then subtracting it, I can do this parallelly. Okay, I can keep adding the new elements and keep subtracting the old elements. How can I do that? So what I can do that is I can traverse through it. Okay, I can traverse through it. So if I traverse from, let's say, 0 to n, okay, less than n, whatever size is there, and I can take a variable, let's say int answer. Okay, so what I can do, I can keep on adding this, okay, and keep on subtracting my number from it at the same time. So first what I can do, I can just keep on adding my I, and I can keep on subtracting whatever number is there. So I can keep on subtracting my number from it. Okay, so what it will do, it will keep on adding. So first 0 will be added, then 1 will be added, then 2 will be added, then 3 will be added, then 4 will be added, and so on. Okay, and I will keep on subtracting whatever number is there at my array. So let's say 3 is there. Okay, it can be in random order. So let's say 3 is there. So first I will subtract 3. Let's say 2 is there. So I will subtract 2. Let's say 1 is there. So I will subtract 1. Okay, and let's say 0 is not there. So at the end, that will be my answer. Okay, so first here what I'm doing, I'm doing this part, and here I'm subtracting my number whatever is present. So I'm doing this part. Okay, so you may think that till now the work is over, but that is not over. Okay, one case is there. So how many times I'm running a loop? So I'm running my loop from 0 till n. Okay, total n times. But how many elements are there? N plus 1 elements are there. Okay, from 0, 1, 2, 3 till n. Okay, one number is missing. So by doing summation, so at the time of summation, what I'm doing, 0 plus 1 plus 2 plus 3. Okay, I'm running this loop smaller than n, so it will run till smaller than n times. Okay, so I'm adding from 0 till n minus 1. Okay, I'm not adding n. So at the end just add n also. At the end just add n also. So answer plus equals to n. Okay, now you can return the answer. See what I'm doing, I'm running a loop from 0 till n. Okay, so n is not included in this loop. This loop will run for n times only, from 0 till n minus 1. Okay, but I need to do summation from 0 till n, okay, including n. So either include it here, or you can do, you can just add I plus 1 here. Okay, and you don't need to edit here. Okay, that's also fine. That's also fine, because every time what I'm doing, see, n times loop will run. So answer plus equals to 1, then 2, then 3 till n. Okay, because zero is not contributing to addition, right? So I can add this like this also. Okay, so either add it like I plus 1, or just add I at the end, add n also. Okay, both way it's fine, both way it's fine. So let's take it this way only. Okay, so that's all about this approach. Okay, it will not give you the overflow error. Okay, it will not give you the overflow error. What we are doing, we are adding and keeping on subtracting. So I'm adding, I'm subtracting, I'm adding, I'm subtracting. Okay, so I hope you got this approach. Okay, and what is the time and space complexity of this approach? Time complexity, it will take one pass only. Okay, it will take order of n time, and space complexity, it will take order of one space. Okay, so yeah, this is all about this approach also. Okay, let's move forward to next approach, which is our third approach. So let's discuss the bit manipulation approach. Okay, the approach is similar to previous approach only. Okay, but we are you going to use bitwise operators. So we have given, let's say, 0, 1, 3, 4. Okay, and 2 is missing. So what we can do, we can, if we can perform XOR operation. So if I perform 0 XOR 1 XOR 2 XOR 3 XOR 4, okay, with my array numbers, so 0 XOR 1 XOR 3 XOR 4, okay, so this will cancel this, this will cancel this, this will cancel this, this will cancel this. Okay, and I will left with the missing number. Okay, so this is my approach. Now how I can do this? So again, I will traverse the array, let's say from 0 till n less than n. Okay, and let's take a variable XOR outside. Initially it will be 0. Okay, and I'll keep doing XOR with my number. Okay, let's say nums of I, and again keep doing XOR it with I plus 1. Okay, so why I plus 1? Because I is 0. So if I start from 0, 0, 1, 2, 3, so and will miss. Okay, so better if I take 1 XOR 2 XOR 3 XOR 4 XOR till n. Okay, you can do the same thing. If I take XOR with I, at the end I need to do XOR with my n. Okay, so to avoid two conditions, I just take it I plus 1. Okay, so at the end, whatever the value of XOR, that is nothing but the missing number. It is nothing but missing number. Okay, and how much time it will take? It will take, again, time complexity order of n, and space complexity order of 1. Okay, but the previous approaches also took order of n time and order of 1 space. Then how is it different? Correct. So here nothing, both are optimal, right? So previous approaches are also good, this is also good. Okay, but we are using bitwise operator here. Okay, I wanted to teach you this problem using bitwise operation. Okay, now if both are good, what can be my brute force and better? Okay, I forgot to discuss the brute force and better approach, so let's discuss it here also. Okay, what can be my brute force and better approach? So you know it very well. I think if any brute force approach you want to find, just start with two loops. Okay, start with two loops. So if you take two loops, just search whether this element is there or not, there or not. Okay, if that element is not there, that can be your answer. In better approach, just try to take map or hashing. Okay, so store all the elements in map from 0 till n, and iterate the map. If the number count is 0, that means that is our answer. Okay, anywhere in the interview, if someone asks you brute force or better, just try to think of two loops and then try to take a space. Okay, so here the time complexity will be optimized, but there will be space. Okay, so start from order of n square, then move to order of n time and order of n space, then try to optimize the space. Okay, that's how the problem goes. So that's all about this problem, and I hope you liked it. There is nothing much in that problem. Okay, so if you understand the basic concepts, just try to take care of the overflow underflow problems. Okay, these are the edge cases. See, problem intuition you can solve. Okay, but the edge cases are there, so please try to cover edge cases also. Okay, that's how the critical thinking is analyzed. So that's about this problem, and let's move forward to next problem.